Hey guys, hope you guys are doing well. We are going to be practicing some of the math equations using the formulas that I have shown you guys so far. I'm going to do them just like I do in class. That way with the video you guys can stop and go back and rewatch as many times as you need to. But you really have to pay attention to the ones that I do today because it will help you with the section B questions that you will have on Friday. The first one that we're going to do is the percent by mass. Now we had done an example in the PowerPoint and the one that I put in the PowerPoint was a lot more difficult. So I'm just going to give you guys an easier one. Know how to do the one in the PowerPoint, but we're just going to be using the mass of solute, which if you guys remember, the solute is the thing that is being dissolved, over the mass of the solution. And remember, solution is both the solute and the solvent combined. So a really easy example is if I say I have 3.5 grams of salt, you guys know as NaCl, and I have 70 grams of solution. The question would ask, now what is the percent by mass? So given that this is my solute and this is my solution, you're going to put this one over top of this one, just like the part over the whole times 100 that we have done previously in this class. Solution, and then you do times, I think that's not showing on the camera. So whatever you get from this, so 3.5 divided by 70 is going to be 0.05. And then you have to multiply by 100 because that is always needed in order to make it a percentage. So when we multiply that by 100, you get 5%. Okay? I will label this one as question number 1. So in the thread underneath the video, if you need to, you can say question 1. And if you have a question, just go ahead and ask me so I'll know exactly what question you are referring to. Okay, but those ones are pretty easy, pretty straightforward. And again, we've used this general concept of the formula multiple times in class so far. So let's move on to a little bit of some more difficult ones. And they're not really difficult because at this point you guys have done so much math that you guys are going to be experts. Okay, so the next problem has to do with molarity. Okay, we talked about molarity and molality, how we have the big M and the little m. And the difference is for molarity, we are dealing with moles of solute over liter of solution. Okay, so I will be reading you a problem. Again, it's very important that you pay attention to what I do now because when you go to do your homework questions, they're going to seem super easy because they're going to be very, very similar. All right, so the question says, what is the molarity, so that we know we're using this formula right here, of the solution that contains 3.4 moles of 4.2 moles of solute in 175 milliliters of solution. Okay, so I'm going to write down what the problem gives us. So we're looking for molarity. Okay, that's what we're solving for. That contains 4.2 moles. So we have 4.2 moles of solute. Okay, so this one is very straightforward. It gives you all the numbers. In 175 milliliters of solution. Okay, so we have our moles of solute and we have this number for solution, but there's something wrong with it. In the problem, they give it to you in milliliters and we need it in liters. So again, you guys, if you do the King Henry died by drinking chocolate milk, this is equal to 0.175 liters of solution. Okay, So that's really the only funky thing that we have to do for this problem. Now we can just plug these numbers in and find our molarity. So we have 4.2 moles of solute. Again, solute is the thing being dissolved, over 0.175 liter of solution. I'm going to write solution like this with the apostrophe N so I don't have to keep writing it out. And I'm not going to just write SOL because we don't know if I'm talking about solute or solvent or solution. Okay, so that's how it's going to look from now on. Right, when you plug these into your calculator, you will get 24, and our unit is the big M. So our answer is 24 molarity. Okay? Now this is going to be question number 2. So in the thread, again, if you have a question for this one, just go ahead and write 2, and then tell me whatever it is your question is. All right? Now next one, find my towel. Okay, for our third question, this is going to be very similar to one that you have in your homework. It's a little bit more involved, so please pay attention to this one. All right, so the question says, what mass of K2SO4 would you measure out to prepare 650 milliliters of a 0.84 molar solution? Okay, so our end result, we always write out what it is we're looking for and then write down what you're given. Okay, so you have 650 milliliters, okay? And you have a 0.84 big M solution, okay? So this one is a little bit different because they have given you this number and this number. So we are solving for moles. So you're going to have 0.84, that's our big M, equals our moles of solute. That's going to be our question mark. That's what we're solving for first. So then from moles, we can get into grams because you guys all know how to do that now. Now, 650 milliliters, we want our denominator to be in liters. So that's going to be 0.65 liters. Okay? Now, if we were in class, I would ask you, how do we get the numerator by itself? And you guys would all tell me that we would multiply both sides by 0.65. So I multiply both sides by 0.65. All right, and when I do that, the number that I get is 0.546 moles, and our solute is K2SO4. Okay, but the problem didn't ask us how many moles of it we have. It wants to know how much weight, how much does it weigh. So if I were to tell you to go back in the lab and say, go get some K2SO4, I wouldn't tell it to you in moles, I would tell it to you in mass. Now you guys all know, how do we go from moles to mass? Molar mass. So let's start with what we solve for, 0.546 moles of K2SO4. And if we want to get rid of moles, it needs to be down at the bottom. So 1 mole of the K2SO4, and we need to have the molar mass of K2SO4, which again you get from the periodic table. I will go ahead and do that for you. 174.27. Okay, so when we do that, we're out of our mole unit and we're in grams of K2SO4, which is what the problem asked for. All right, so now we multiply these two numbers because they're both on the top. And when you do this, you will get 95.15 grams of K2SO4. So back to the question, it's saying how much weight of K2SO4 would you have to measure out in order to have a 650 milliliter with a solution of 0.84. This is how much you would weigh. Now, you guys have used hydrochloric acid and a few other things, and on the containers, it gives us that big M. Basically, it's a concentration. Remember in the PowerPoint, we had talked about concentration of something. So if you have a 6M of hydrochloric acid, that's telling you that you have the concentration of a 6 molar of hydrochloric acid, which is very, very high. Okay, that is the point of all of this. So if I didn't have this solution right here of my solution, I would have to go in, weigh out 95.15 grams of K2SO4, and I would have to mix that with 0.65 liters of my water to get my solution. Okay, so this is problem number 3. So if you have a question on that one, go ahead and write it in the thread. And do it publicly. Don't make it a private comment just for these, just in case someone else may have the same question, or your question may bring some clarity to something that someone was confused about and may have not even realized. Okay. And that is our problems. We have one more for molarity. Let's find those words for it. Okay. It says you have a 0.4 liter of a 0.46 molarity solution. How many moles of HCl does this solution contain? All right. So this one is going to require one less step because all we are solving for is the moles. Okay. So I'm going to write what we are given. We have a 0.4 liter of solution, and we have a 0.46 molarity HCl solution. Okay, so now all we have to do is plug these in. So the 0.46 is going to go over here, and the 0.4 liters is going to go down here. Okay, so we're going to have 0.46 equals our mole of solute over top of our 0.4 liter of solution. Okay, and I forgot the unit for that one. All right, so in order to get moles of solute by itself, we're going to multiply both sides by 0.4. All right, and that will give you moles of solute. So 0.4 multiplied by 0.46 is going to give you mole of our solute. Okay, and that's what the question asked for, so we're done. This one we don't have to do the stoichiometry conversion to mass, which I'm sure you guys are thrilled about. Okay, so this one was number 4. And we will move on to our next formula, molality. Okay? So again, it's important that you keep the difference between those two things clear in regards to the denominator. Okay? So now this will be question number 5. And let me find the wording for this one. There it is. Okay. All right. It says, what is the molality of a solution composed of, we have 30 grams of NaCl, okay, and 350 grams of H2O. Now, you might ask yourself, which one is the solute and which one is the solvent. So if you guys remember, solute is what is being dissolved. So that's going to be the lower amount. The solvent is going to be the one doing the dissolving. So that is the one that is in a greater amount. So that tells me that my salt is the solute and water is the solvent. Now, I've said it like a million times, but in case you missed it, water is the universal solvent. So anytime you see water, automatically clues you in that that's going to be your solvent for whatever solution it is that you're talking about. All right, so I have my solute and my solvent, but neither one of these are in the units that they're supposed to be in. So what do I need to do to NaCl to get it into moles? You have to do stoichiometry. Like I said, it's never ever going away. Well, at the end of the year it will. But 30 grams of salt. And then how do we go from mass to moles? I can hear all of you saying molar mass. So 58.44 grams of NaCl. All right, so we're out of grams and we are now in moles. That is 0.51 moles of NaCl. All right, so now we have our top number. So that's going to go in there. Now, how do I go from grams to kilograms? Again, that's going to be the King Henry died by drinking chocolate milk. So you're going to take this decimal that's here and just go 1, 2, 3. Okay? And that's going to make that from grams into kilograms. And that's going to be your denominator number. Okay? So we have 0.51 moles of NaCl divided by 0.35 kilograms of H2O. All right? When you plug that into your calculator, you'll get 1.47, and then we do the little m for molality. So that is your final answer for number 5. All right, so again, have questions, just let me know. And again, the beauty of this is that you guys can pause or go back if I talk too fast. Sometimes I don't even realize I'm doing that. All right, this is going to be the last one that we do before you guys are set loose to do your homework problems. All right, so number 6 says, a radiator is filled with a mixture of 2.75 kilograms of ethylene glycol. So we have 2.75 grams, this is number 6, of ethylene alcohol C2H6O2, ethylene glycol, in 8.35 kilograms of water. Okay, it says calculate the molality of this solution. All right, so looking at this, this number is going to be smaller than this one, because if you were to convert this out, that would be 8,350 grams. So this one is way larger. Also, again, it's water, universal solvent. Okay, so that's how you would label that. So solute is up here and solvent is right here. All right, this one is good. We don't have to do anything to this one because it's already in kilograms. Now, this one right here is in grams. So we have 2.75 grams of C2H6O2. Now, we have to get that into moles. Okay, so in order to go from mass to moles, again, molar mass. All right, so I did write that one there, it's okay. All right, so we have, why do I have that written out like that? Okay. 1 mole of C2H6O2. And over the molar mass of that, which is 62.07 grams. Oh, I'm so sorry. I said this was 2.75 kilograms. That's why I was getting confused. All right, so if that's kilograms, that makes this 2750 grams. Sorry, I had a brain fart. All right, so again, the question said 2.75 kilograms, not grams. So first thing we have to do is convert that into grams by moving that decimal 3 places. And then from grams to moles, we do the molar mass. All right, so we're going to be dividing 2750 by 62.07, and we're going to get 44.3 moles. All right, so this is the number that will go in our numerator. All right, so we have our moles of solute, 44.3 moles, and our solute again is C2H6O2, and that will be divided by 8.35 kilograms of H2O. All right, and when you divide those, you will get 5.3 molality. Sorry about that confusion with the kilograms to grams. If you guys have any questions on that one, please let me know. Again, that was for your molality. So those are all examples of how to do percent by mass, molarity, and molality. Now your homework questions that will appear automatically on Friday at 8 a.m. So you guys will have Friday to work through those after you view these today. And I want you guys to have all of these written down in your notes or on a separate sheet of paper for examples of how to do all of these. So then when you go to do them, you can kind of look back on your work and use the same ideas to answer your homework questions. Okay? For your homework questions, it's going to be a lot of molarity and molality questions. The percent by mass, since we've done percentages multiple times this year, I'm not focusing on that as much in your homework questions. So that is all. Also, keep letting me know if there's anything that I can pray for you guys about. I am praying for all of you. I miss you, and I hope everyone is doing well and feeling good and enjoying time with their family. All right, see you guys.